MIDAS nGen, we call it as nGen because it's the next generation solution for buildings, analysis and design. It is the combination of analysis plus design plus drafting in a drafting tool all in one. So you do not need to go for any other software solutions. Just use MIDAS nGen and you get it all. Have you ever thought like CAD programs like AutoCAD or Tekla, which draws the drawings or shapes, and C products like there are some products like STAT or ETABS which interpret and design? Are they like combined together? Can we actually make the CAD drawing and the CAE drawing like an analytical model itself? Or can we have the analytical model as a drawing, structural drawing? So basically, what I mean to say is, can you connect CAD and CAE, that is shape modeling and analysis modeling, together? So basically, this is what MIDAS nGen does. MIDAS nGen combines CAD and CAE software, makes it a CAED kind of a software solution because it is integrating CAD and CAE softwares. You can have shape model which can generate drawings and the analytical model in the same software solution. So as you can understand, you are absolutely free from meshing. You don't have to actually think about the difficult concepts of finite element, meshing or nodal connectivity, which are the concepts used in the analytical models. The most important concept of MIDAS nGen is drawing to drawing. So all business processes can be integrated into one using nGen. There is automation which can reduce the production time significantly. And with the help of optimization, you can get enhanced optimized quantity takeoff. And there is high quality of design deliverables provided by MIDAS nGen. So it is an all-in-one design system for civil engineering field, basically structural field. Now let's look into the application areas of MIDAS nGen. There are applications, or you can use MIDAS nGen for apartment buildings. You can use for concrete frame with steel roof, like two types of materials in a single software solution. A car park and building, then a multi-towered structure, a shell structure as well can be done along with the frame structure. Then complex facilities, as you see over here, can be provided in MIDAS nGen. We have got plate beam kind of an element which can have the slabs at the top, at the central position or at the bottom wherever required, like the drop slab. You can have irregular structures. So there are curved surface shaped analysis can be performed by MIDAS. Very easily you can draw or you can model these kind of structures in MIDAS nGen. Coming to a very good example is of an informal building wherein a curved surface shaped analysis can be performed. So as you can see here, this is a stress analysis for all the curved shell elements here. You can have more than one tower connected to a common podium in MIDAS engine. Why I'm actually showing this is because each tower has got different diaphragms, and these two diaphragms for each tower can be separated easily by using modules in MIDAS engine. Last but not the least, we have steel and RC frames that can be analyzed and designed in an optimal way in MIDAS engine. We shall be looking today at a steel structure. So let's go ahead now to the demonstration part in MIDAS engine. Before we start ahead, since it's a training, I would like to introduce you to the user interface of MIDAS engine. The user interface includes the ribbon menu at the top, which is divided into different tabs as per the work procedure from left to right. So you first start with the modeling and definitions of the structure, then you apply the loading, then apply the boundary conditions, perform the analysis. You can also provide design information, perform the design, and check the analysis and design results at the same time. And after that, you can go ahead, generate reports and drawings. So from left to right, you can have the drawings generated from the drawings that you have. Alright, so there are various ways in which you can create a model in MIDAS engine, and we will be showcasing all of these modeling methods in each of our training sessions. So I'll just quickly introduce you what all types are there. Firstly, there are importing types, wherein you can import MIDASGen text file, you can import stat file or parasolid files. Then you can import the DWG or DXF files. It could be 2D or 3D DXF file import. You can start creating your model by tracing a CAD file, an architectural CAD file. Then you can generate grid lines and then convert those grid lines into members, or you can simply go ahead to members tab and start drawing your members without the necessity of any grid line or with the grid lines. So today what we are going to be doing is we will be defining the grid lines, and then we will be creating members on top of the grid lines, like using the grid lines. So there are various methods, and that's what we are going to be seeing today. That is a grid line method. Alright, then further in the user interface, we are going to go through several tree menus that are available over here. And these tree menus are very intuitive. Basically, whatever you define will be displayed right over here. And that is how you can confirm what all things have been incorporated in the model file. Then further, if you would like to check the properties or do the modification of the properties of your members, then you can directly go in and look over here at the properties tree menu, make any modifications over here, and your member will be modified accordingly. We can have more than one model file opened up in the same window, and we can work on two files or more than two files simultaneously. This saves a lot of time. Now at the bottom right over here we have the unit system right now, which is by default in Newton meter. So I'll change it to kilonewton meter for easy information, to provide information easily. Alright, so that's one thing. Now let us go ahead and start with our structural modeling. So firstly we are going to go ahead to the define tab and define the material and the section properties. So there are various methods in which you can do this. Like you can first draw the geometry and then go ahead to the definitions, or you can first define and then go ahead for the drawing. Alright, so firstly let us look at the material properties. MIDAS engine can handle steel as well as concrete like I mentioned before. So here we are going to be doing steel structure, having a steel material property. We have got various standards available for quickly defining the steel as per different codes that you're using. Alright, so if you're using EN05, you can select from here all the like one of the grades of steel as you require. So S275 is what we would like to check, use. So, and yes, this training session is on Eurocodes. We can also go ahead, perform the analysis and design using other standards, which I will be showing, like just showing the list one by one as we go ahead. So like I said, over here we can use different standards for material property definition. This is the elasticity definition for our material. We can also look for the strength definition, and for dynamic analysis, the model damping ratio can be seen right over here. So you can do the modification right over here. We're going to be performing static analysis for this structure, linear static analysis. So we'll go ahead now and we can click on OK to finish the definition and close the dialog box. We can also click on apply over here so that we finish the definition, but still keep the dialog box to go ahead and define the next property definition. By default, there are some material properties already defined in your newly generated MIDAS engine file. One is a steel property and the other is a concrete property. Since we already have the steel property, we can use it and go ahead for the next definition. The next definition we'll see is for 1D sections. Now we have a very good advantage in MIDAS engine regarding the section definitions. In many programs, you have to go to different softwares like a different module to generate an irregular shaped or any different kind of a shaped section property. However, in MIDAS engine, in this area itself, you can have any general shaped, any irregular shaped section property defined. Alright, so let me go ahead now with the predefined section properties as per the standard use. So we can see over here there is American standard, British standard, and we have Indian standard as well. If you're using any of these standards, you can easily select and then select the type, like H section, that is the I section actually. Then you can select from the list all the different types of section properties that are predefined in the software solution. So I'll go ahead and define them. So firstly, let's define a column section, 152 subsection actually, 152, 152, 37. So this is the one. Insert the template, that's what you have to say for having this particular section property inside our workspace. And then further we can provide over here the information like the name and the material property. Yes, in MIDAS engine, you can assign the material property to the section property directly and then assign that section property to the members. Alright, so this is one important part. We can also import CAD files to create our irregular shaped structure section property. Alright, so I have just done insert template section. Now I simply say apply. Then let's go ahead, define another section property. So that will be UC 356, 368 and 129. Insert template section, click on apply. Then a UV section property, that's 305, 165 and 54. Insert template and click on apply. Then let's go ahead with another UV section, that's 406 by 178 by 74. Insert template section, and apply. And we'll have another property. This will be for the braces. So let's use the angle type of the section, and we will go ahead with an equal angle of 100, 100 by 10. Insert the template and click on apply. As we go ahead and keep on clicking on apply, we can see over here in the tree menu how the section properties are being created. Alright, so here we go. We are done with the property definition, that is the section property definition. Now let's close this dialog box and we'll go ahead with the next part, that is to define the grid lines. So here we go. We are going to now click on this define or modify grid line. Alright, now here we are going to be providing the information for the X direction, Y direction and the heights. So in the X direction, we have got 7 numbers of bays at 5 meters center to center. Then in the Y direction, we can use 4 numbers of bays at 5 meters center to center. Then we have two levels over here. That's what we can define. 2 levels at 5 meters center to center level. And then we can choose to put it at any location by using this base point information. Just click over here and set it anywhere else. And then click on apply. Alright, so here we go. We have created our section property. We have created our grid lines. Now, in case you would like to do modification in the grid lines, that is also possible. So in the define grid line itself, there is modify grid line option. Alright. So here we can choose which is the grid line that you would like to modify, if it's the X, Y or Z type of direction. This is one way in which you can do the modification. Another way is by clicking on define modify and then clicking on this dialog box to actually look at the table of the grid line information. So in case I want to change the Y grid line spacings, then I can do that. For example, over here, this we can make it as 7.5 and this we can make as 10 and this we can make as 20. And then further we can go for the level, modification of the levels. So here we can have there are many right over here. You can just delete them. So we have one level which is at 8.5 and we have another level which is at 10. Don't have a level at the 20th way. So this is how we can go ahead, do the modification over here itself, and then we can click on OK. So this is how we have modified our information.
But it was not, it was not in a separate
Alright, there's some issue in the audio. Yeah. Okay, So yes, now over here actually we can see two grid lines that were created because I made it twice. So we have grid set 1 and we have grid set 2. So there is this grid set 1 which we can actually delete and make use of the grid set 2. It's a So these are the different grid lines that we have over here. Alright, now let's go ahead. Using these grid lines, we are going to start creating our members. So to create our members, we can go directly now to the member tab, and in the member tab, we can start creating beams, columns, braces, sub-beams, sub-columns. Now over here, we have the brace type of member, sub-beam and sub-column type of member. Well, the difference between these members and the beam and column member is about the beam and releases, which are automatic in MIDAS nGen. So if in case, usually like sub-beams, they have pin-pin type of connection. So for that reason, we can actually go to the Structure tab and look at the global settings. In the global settings, there is modeling option, and here there is sub-beam, sub-column and brace type of elements or members, I would say. And for these members, what are the connections or releases provided by the program automatically are given. You can modify this, you can make it pin, fix type. And if there is anything else, then of course you can do the modification in the boundary tab. Alright, so this is the type of member that we are going to be creating. Firstly, let's start with creating beam type of member. So for the beam type of member, from here, firstly we'll select the correct section property. So for this beam member, I'm going to be selecting UB406, and we'll start creating by simply clicking on the intersections, and we can press escape from the keyboard and go out of the command, and when we want to come back to the command, we can go ahead and press the space bar, and now we can simply create the same property using the same section property, the same member. Press escape again and you're out of the command. Similarly, you can go ahead, use the column type of a member, and for the column we can select, let's say, UC305, and from here to here you can create the member, again pressing escape, pressing spacebar. From here to here we created a member. Alright, so here we have our main frame of beams and columns. Now these members can be copied further at other locations. So these other locations that we have can be done by using this copy command. You simply select by dragging a box around these members which you would like to copy. I've selected both beams and columns. And then again, we do have two options to use for performing the copy. There is this one option which you can drag and put it at any location as you desire. Likewise, or you can use this snapping tool, like by selecting 2 points, you can click on one point and then click on the other point and specify the distances. So that's what I'm using right over here, using select by 2 points, and there we go, we're done with our main frame. Alright, now let's go ahead and create some braces. But before braces, we'll firstly start with purlins. And the purlins can be created using the sub-beams, because the purlins are having pin-pin type of connection on our main beams. So using the sub-beam option, I can select, of course, from here the other type of section property, and I can simply click on one end to the other end. Now, even though I'm clicking from one end to the other end, the elements in between are helping the element I just created to be intersected. And this is just because we have got the auto intersect option on. So in case you are, sorry, this is how it's supposed to be on. So, right, let me press undo. Yeah, so here we have auto intersect. So you need to take care that your auto intersect option is on so that your subbeams or your elements are generated with automatically intersecting intersection. So here we go, we have automatic intersection of all these elements that we just created. Alright, so that was about the subbeam. That was just one created right now. Similarly, let's go ahead and create the subbeams at other locations. So before we go ahead and use that other location, I'm going to be selecting this sub-column type of a section which will be spanning from here to here. So I'll go ahead and use UC itself. UC 305 I'll use. So I'll go from here to here. Similarly, here to here. So we have our sub columns, and I can copy these sub columns again from this location to this location. Alright, now I have got a point right over here. So this point can be taken and utilized for creating the rest of the purlins. So from here to here is one purlin, and similarly we have a purlin from this point to this point. Alright, now further we can go ahead and create more purlins at different locations, and then further copy the purlin in this way from this point to this point. So we are done with creating the purlins. Now let's go ahead and create some girths. So those girths can be of the type of beams itself. So here maybe I can choose a lesser size for the beams, maybe a 305, and then I can start from one end to the other end. Similarly, I can click at this point. This could be the center, or you can also make sure that that point particular that you're selecting is a perpendicular distance. So for that you can actually go to the modeling snap tools. So here we have got settings for the snapping option. So modeling snap is right over here. So you can snap on. You can, instead of choosing center point, you can use the perpendicular, and you can click on OK. So from here now you can basically select the perpendicular distance that can be provided by the program. So right now, as per the model that I've taken, for example, it is using the midpoint. So this is how we can go ahead . So the modeling, as you can see, is pretty easy right over here, and it's all because we have got the escape and spacebar options to easily go in and out of the command and easily create the structural drawing or the structural model, not the drawing. Alright, so we are done over here creating the girts. Now we can also go ahead and create the braces. So for the braces, we are going to be using the equal angle section. Alright, to create the braces, I do not want any intersection. So I'm going to be saying auto intersection off, and then going to be just clicking on the nodal locations wherever I want to create the braces. So these are the locations where I want to create the braces. So as you can see how easily I'm able to create different the braces at different locations without having to click many times. Just need to take care about the cross marks. So wherever the cross marks are, that's where the intersection is. These are actually some modeling tips that you can get from the sessions that we're conducting right now. And I'm able to rotate my model with the help of the scroll bar button. Okay, so in the mouse you have the scrolling button which you can make use of. And when you're pressing the scrolling button, that is the central button of your mouse, at that time you can press, at the same time you can press Control so that the rotation will take place automatically. Alright, so I have created some braces that are like at one location. I'm going to be similarly creating the braces on the other side. So either I can do the mirror command or I can use the copy command. Alright, so we have got this another good option to simply select all the braces together in a very simple way by simply going to member type of selection, and then over here we have different members. So I say unselect all, and then I can use the brace truss type which we have just created. Then click anywhere else, and then you can go ahead, simply make a box around the entire structure to select only the braces. Alright, so now you have all the braces selected. Next thing you can do is simply go ahead to the mirror. Alright, so here we have the move type and we have the copy type. So you can use the copy type, and then you can use the plane option, or you can select 3 points and make the plane. So I'm going to be selecting 3 points right over here. So there's 1, that's 2, and that's 3 points. And this is how our mirror is going to take place. So click on apply, and then we are done. Alright, so this is how we are done with the mirroring of our braces very easily. Now further, I can also do some tricks, like I can just ask the software to have only the upper level to be visible for me to work on. So I can select the upper level only, like number of elements that I want to look at only, and then right click and say show only. And after that we can go ahead on the top view, and then we can make use of this structure. Alright, so there are a lot of grid lines as we have on our structure, but we do not want to make use of it, so we'll right click and say hide all the grids. So now we do not have any grid lines, and now we can simply go ahead and freely draw our members. So here we go, the braces are already there with us. We can simply go ahead and use the copy tool, select the braces, use the 2 points, and simply click on 2 points. Oh, sorry, that will be wrong. We'll have to select these two. Use this option and go ahead. Alright, that's done. let's right click and say all members. So there are really good options of right clicking. Also, when you click on the scroll bar, you can go to your isometric view, then you can go to different views like left, top, right, bottom, back, front, and all. Alright, so we are done with our model. Now let's look at some really good features that are additionally available in MIDAS nGen. One such good tool is the auto edit type. In the auto edit type, the members which are undivided or the members which have been divided unnecessarily will get automatically divided or merged. So we will use this auto edit function, and instead of selecting the braces, because if we use this function on the braces, then they might get divided, which we do not want to at the location of intersection. So we are going to be like over here, unselecting the truss, member brace truss, and then further we can simply select the entire structure. As you can see, the braces are not selected here, and then click on apply. Alright, so this is how we are done with the divide and merge. Now let's go ahead and use this intersect option. So again, this intersect option is for those locations where the members have not got intersected, not got divided because of the elements that are coming in between. So for that purpose, again, we're going to be like saying select all. Okay, not select all actually. Here again, we need to unselect the brace type and then select all. Alright, and after that, we'll click on apply. So now as you can see, these members are successfully divided into number of parts, and that further can be used for performing the design correctly. Alright, so we are done with the auto edit and intersect option. Now we have got the generate option, which is again an automatic feature for reflecting the connections between member types. So let's look at that. So there is generate tool. We have got the section offset that can be created by the software automatically. There is start and offset, and there is cut back. So all these things will be taken care of by the program automatically. So here again, I'll say select all and click on, okay, before I do that, let me just show you very quick, like in a zoomed view, what exactly is going to happen. Alright, so as you can see over here, these members are like at different locations. They're not at the correct location, and also they're overlapping. So what the program will do is, it will, when you click on OK, it will take care of no overlaps, and it will take care of the section offsets. Right? So this is done for all your members. Similarly, in case you would like to do the modification of any member types, like specific members, the section offset, if you would like to provide, then that can be done by simply selecting those members. So I'll select the braces for an example. Unselect all braces, go to the front view and select the top braces especially. Alright, so here I have selected braces, and at the end, okay, I have the option offset point, which is center to center, that can be changed as a center top. And that's it. You are done with modification of the section offset of your members. So it's that easy. I'll show in the zoomed view. So this is what the situation was, and this is what we have modified. Okay, so with the help of accurate modeling or practical modeling, we can get more accurate results. Alright, further let's go ahead now to the next part. That is the load set. Okay, loading part. Okay, so firstly we are going to be creating load sets. Load set as in kind of load cases, like dead load case and live load case, like that, which will be used for the combination purpose. So we are going to define those load sets using the define tab. So there is this load set option. We have static load set option in which we are going to be creating one for the dead load. The type will be dead load type itself, and we'll have one live load. The type of live load will be modified from here and add. So we have these two. That's it. That's for the static load cases that we by ourselves have to define. Excuse me for some technical problem here. Alright, we are back. So we are going to be defining the load sets. Load sets were defined. Now we'll go ahead and apply the loading. The dead load, live load. We'll apply wind load, seismic load as well. But for wind load and seismic load, the load sets are automatically generated. So we need not worry about that part. Alright, so let's go ahead to the loading. The first thing that we are going to load the structure with is its own self-weight. So we have at the leftmost side self-weight command. All we need to do is put it under the correct load set and just click on OK. Now this is the mark for the load set application, as you can see right over here at the center. Okay, so this can also be verified with the help of the analysis tab, tree menu. This is the analysis tree menu in which we have got static load option, and you can expand it. You can see the load types that we have generated, dead load and live load. Then under the dead load, we can see that there is self-weight that has been applied, and we can see over here what is the self-weight factor. So basically we can view and display, undisplay the loads that have been applied on the structure. So I'm displaying the self-weight now, and we'll go ahead apply the next loading on the structure. We can apply point loads, beam loads, and there are arbitrary loads. Arbitrary loads are like you do not have an actual element at that location, but there is like actual element, like let's say a partial loading on this particular element is required, or then that can be performed by creating firstly a line body and then applying the arbitrary load on it. There are various functions. There is arbitrary point load, arbitrary line load, pressure load, and so on. We will be seeing all these different types of loadings in our future or further training sessions that are going to take place. Alright, so now when it comes to a steel shed like we have over here, we are going to take a look at how to apply the roof loading with the help of the flow load command as we have over here. So this is a command which does not actually require any plate elements to apply the loading onto. Alright, so the first thing that we need to do is create a load type. Okay, so we can provide the name to this load type like a roof loading. Alright, and we can have two sets like load cases like dead load and live load applied on the roof at once. Now here I'm going to be providing a small value for the dead load, that would be of the roofing or the sheeting that you can say, and -1 for the live load, and add. Alright, so that's about the loading type that we have created. We can create more number of load types in case you have got any floor in between. Alright, after the load type has been defined, we'll go ahead and assign this floor load by using this floor load tool. Alright, so here in this floor load tool, We have the load type as roof loading, which we just defined. If you want to define some more, then you can click on this dialog box and get to that command again. Now next part is load distribution. There are one-way, two-way, polygonal centroid, polygonal length type of load distribution. Basically, the rest of the three are available for us to apply the loading on an irregular shaped area. One-way loading will apply on a rectangular shape itself. Alright, again over here we have the angle. Now this angle that we are looking at is nothing but the angle of the load application based on the direction that we are choosing while we are applying the load. So once I apply the load, you will understand what is this angle is about. Alright, so we have to add now the area. So we'll click on the flow load area and we will start defining by clicking on the shortest distance first so that the one-way loading is applied to the longer distance. So that's the shorter, then we start with the longer side and then this. So we have over here a preview of the area of flow load and then we click on apply. That's one flow load area, you can see right over here. Now let's go ahead and define another flow load area. So again, I'm going to click on the end locations of my floor area and apply. So I've got two numbers of floor load areas, then I simply click on OK. And as you can see over here, the one-way roof sheeting load has been applied successfully on the coordinates. Alright. We can confirm this application by looking over here. So we have under the dead loads of flow load and I can uncheck this and then further we can look at the live load. You can see it right over here as well, that is -1 and over here as well in the tree menu. Alright, so we are done with the live loading with the help of load load, so I have undisplayed that part. Now let's go ahead and apply the wind load on our Untitled structure. So for that, let's firstly go to the wind load function option, and here we are going to have code-based type of wind load applied to our steel structure. This is actually an advantage in MIDAS nGen, wherein you can have code-based loading applied directly on the structure. So how is this going to take place? So let's look at it now. We'll click on this three-dot box and go to select the code that are available. So we have the American standard and we have the European standard and the British standard for the wind load application. In this training session, we'll be applying the European standard and the national annex utilized would be the recommended one. Now for applying the lateral loads, usually in many programs, we need to create the story definition. However, over here, we do not need that. We can simply provide the information by ourselves, provided that we have the information. Of course, we will have the information, we are making the model itself. So our height of the structure from ground level is 10 meters, that's what we're providing here. And then further, we have the basic wind speed. I'm keeping the information the same. We can apply the orographic effects and neighboring high-rise structure effects. And if there is any displacement height effect that you would like to consider. And the next important part is the structural factor. And this structural factor can be actually automatically calculated by the program. And that can be done by clicking over here. Even though there is no story information, we can still create or we can still get the structural factor, and that's by simply providing the information for the along wind and across wind information and the natural frequency of the structure along the wind. So that is 5.1. That's what I've already found out, and then we can click on calculate, and this is the structural factor that we get, which we can utilize further. You can also manually calculate and provide the structural factor by yourself right over here. Next is the pressure and force coefficients that will be utilized. We partially enclosed type of a structure, and we can consider the internal and roof pressures. and those can be automatically calculated using auto calculation of pressure coefficients option. So here again we can provide the information like what is the major breadth and what is the orthogonal breadth, and the type of the roof. We have dual pitch roof right over here, and when it comes to X direction there is no slope, there is 0 degree slope, so no slope at all. We'll keep it 0 and click on OK. So now as you can see over here, these are the coefficients which will be utilized by the program. So we'll click on OK and we'll provide a name to this function that we're defining as X direction and click on apply. Let's also create a function for the Y direction, and the difference would be simply creating another function by changing the information of especially of the structural factor, wherein our along wind breadth is 35 and across is 15, and this is the same. And further click on calculate and click on OK to get the structural factor, and then the internal and roof coefficients will be automatically calculated by the program. Again, specify the information, provide a dual pitch roof, and now the slope, which will be in the Y direction, it is already calculated by me, so this is 11.3, that's what we provide, and click on OK. So we have got our coefficients right over here, and we are done. We'll click on OK, and we'll click on OK again to finish with the Y direction wind function. Now these wind functions that we have just defined can be viewed from here. Functions, wind load function, and X direction and Y direction. Alright, so these are important things. You can even right click modify, and you can see over here about some more information like a report that can be generated by the program. So these are like few of the advantages in MIDAS engine, wherein you do not need to actually rely, just have to look at what exactly the program is doing inside the software and then believe in it. So that's the point. Alright, so that's about it. Now let's go ahead and, okay, this is what I'll show, the report that is going to get generated. Okay, so we have a report over here for the wind function that was just defined for the X direction. So you have all the parameters right over here in front of you. This is the wind pressure that's going to be applied, I mean the coefficient specifically. And all we need to do now is specify the plans, that is the windward and leeward plans and sides and everything. So for that, we're going to go ahead to the next part of wind load definition, that is assigned wind load. Alright, so in the assigned wind loads, we'll go ahead to the enclosed type of area. Alright, so basically we are going to be seeing over here all the loads that are applied on the structure. So here we are going to be not creating the orthogonal side. We'll have a two-way type of distribution, and now we'll start defining the windward and leeward areas. So when it comes to X direction, we are going to specify by clicking on the endpoints. Okay, let me define again. Apply. And the leeward side, alright, then the side walls, this is the A side that I'm using. Then the other side. Alright, so this is it, and then further we can define a friction area as well. So there are different options. If there is any internal pressure, positive, negative, you can apply here. And then the direction of the wind loading and the wind load function to be utilized. And the scale factor, so we're not going to be using the orthogonal directions, so that will be 0. And then we can click on apply over here and go ahead for defining the other side. So we have applied the wind load in X direction. Now let's go ahead and apply the wind load in the Y direction. The wind load case names are going to be right over here, which you can also modify by yourself. Again, over here, I'll define the windward. This is the windward direction area. Then the leeward area. Apply. Then we have the walls, windward walls, which is for the orthogonal direction. I think it's actually, time is actually up. We were going to have a 1-hour session. However, this is a training session. It might take a little bit longer time. So in case you are not available further, I'll send you all the videos, those who are attending. And then further over here for the roof definition, so I'll go to the home view and provide over here the windward roof. And the leeward roof. Alright, so that's done. We are going to provide this function in the Y direction. Alright, and then we'll click on OK. So we are done with the application of the wind loads in the X and Y direction. We can look at it right over here. That's 1 and that's 2. Now this one again we need to simply modify because it's the angle actually was taken as 0 itself. So we need to take the global Y direction here and then click on OK. Alright, so now we have applied the loads in both the directions, wind load 0 and the other wind load in the Y direction, that is at 90. Okay, so now let's just turn off all the loadings that we are able to see on the structure, and we'll go ahead now to the next part. Alright, so that's how we can provide the wind loads. Now we'll go ahead to apply the static seismic load. Again, it's very simple definition. Just define the static seismic load from here. We can provide the design seismic load automatically. Okay, that's for the building. Let's go ahead with the general type of a structure that we have. And for that, we will apply the wind loading as per the European standard itself. Now over here we have an advantage of period calculator, which is automatic. Just have to provide our own heights and get the period calculated in both the directions. Click on OK and close, and then further apply it to our entire structure. So we can apply the major and orthogonal direction at the same time. So that's done. So our static seismic load has been applied to the structure. Further, we can apply response spectrum loading, earth pressures and perfection loads on the structure as well. And good options are crane loading as well when it comes to industrial type of a structure. Alright, now we're done with the loading. We'll go ahead with the boundary conditions. In the boundary, the first important part is the support that we need to apply. And for the support, we have pin side. So we can go to the front view and we can do the selection of the bottommost nodes of our columns and click on OK. Alright, so we're done with this. And the next part, when it comes to seismic analysis, we need to convert our loads into masses. So that can be done in the boundary tab itself. So I'll have 100% of the dead loads and 50% of the live loads. And we can click on OK. So all this information that I have just right now utilized can be seen right over here itself. So when it comes to the support, we can see the support right over here. And when it comes to masses, we can see the masses applied from here as well. Alright, so let me display the mass from the screen. Next good part in MIDAS is about the auto-generate command, which is like the panel zone effect that can be applied to the entire structure. Next, let's go ahead now and look at the analysis settings. So we have got some analysis settings which takes care of the mesh size, and you can also have the number of processors increased for the analysis purpose. And also you can enable GBA accelerator for increasing the speed of analysis. So the analysis time required is much reduced when it comes to MIDAS family programs. Alright, so next part is about combinations which we can create for our steel structures automatically. Simply select the standard, and as you can see, for the ultimate limit state we have the fundamental and accidental case combinations, and also when it comes to serviceability limit state, that time characteristic, frequent, quasi-permanent, fatigue, such kind of load combinations can be automatically generated. So here we have the automatic generation of the load combinations, and the envelopes for each and every are created automatically. Now we'll go ahead and create an analysis case. In MIDAS nGen, we have a very good advantage in which we can create n number of analysis cases and run them at the same time. So here I can select any of my loadings or members, and then we can click on OK, and then simply go ahead and run the analysis. Okay, so for running the analysis, we can firstly save our structure, and then we'll go ahead and perform the analysis. So over here you can see this is the location where your messages will be displayed, and after the analysis is over you will get a message over here in this window as a warning and error. So this warning that we have is just telling us the auto constraints were removed, so that's just a warning. Alright, then further we'll go ahead and look at the analysis results. In the analysis results, you can see over here there is a tray menu opened up for us to take a look very easily. Simply double click on the results, like there is displacement result. If you would like to see the deformed shape, you can check on the deformed shape and you can scale the deformation as well. Make it 0.25, or you can even see a real-time deformation of the structure. You can also look at the values on your screen itself along with the legend. So legend option is right over here. So you can choose the legend to be visible or not. So it's very easy actually by just using the checkboxes options and then looking at the results very dynamically. So again, we have the exponent type of results. As you can see, this is where the results has been displayed. Or you can even increase the decimal points to look at the results. Then you have this absolute max, so you can check out the displacement of each and every node on the structure. Then here again you can look at the combination results. You can select any of the load combinations. Alright, and then find out what is the displacement. So that's about the displacement. Similarly, you can get the reactions like forces in X, Y, Z, moments in X, Y, moments 1, 2, there actually we have provided pin support. Then the truss forces, like the actual forces can be displayed. Like to take a look at the beam forces, that's also available, like bending moment results. Alright, then further we can also take a look at the results in the form of tables, which is right over here in the table tree menu. So in the table tree menu again, we can just expand the analysis and we can look at the deformation results by double clicking on here. We can say all of the nodes, or we can also use the selection tool to look at the results as we require. So at these locations, I want to know what is the result. So here I've selected those nodes and we have gained whatever the displacement desired. Not desired as in for what we are especially looking at. So this is how we can take a look at the table form of results, and we can take a look at the display in the form of values, legend, as well as diagrams. Now let's go ahead with the design part. So I'll firstly start with the design settings. So here we have design settings for steel sections directly. We can look at these options available. So we can see the partial factors utilized, the strength checks, and the general section strength checks of visibility, fatigue check. All this information is right over here, which you can check and modify. Okay, that's about the design settings. We are using Eurocode. However, the designs that are available in MIDAS nGen is as per American standard and British standard as well. Now let's go ahead and look at the combinations. We need to create actually load combinations for designing. Already we had created the combinations at the time of analysis, which will be utilized again. Alright, so just take care that the load combinations are generated so that the design will be performed. Next, it is important to create design groups, and again these design groups can be automatically generated in MIDAS nGen. So here there is auto select command, and you can just provide over here the level of detail, manual type of naming rules, like you have steel beam, RC beam, crane girders, different naming rules which you can manually change, and then click on OK. And this is how the loads have been applied. I'll just go to the results part and do the initialization of a structure so that we can see how the groups have been created. So the same section properties are going to have the same names, group are going to be put in the same group name. Alright, so now let's go ahead to the design again and look at the member parameters that are available. Member parameters, like when it comes to steel, you can select different types of members, columns, beams, braces, and so on. And you can look over here, specify our target ratio. So depending on this target ratio, we will get the contours for the design results. Then the effective length factor can be automatically calculated by the program, which you can also provide manually. Unbraced length also automatically calculated. There is equivalent moment factor, FB and LTB, again program calculated. If you want to check torsion, if you want to provide live load reduction, then further there is a deflection check that can be performed by the program, and there is fatigue check as well that you can utilize. Alright, so that's about the member design parameter, which you can assign to separate members. For now, the member parameters which are by default available are assigned to the entire structure. Now there are different check positions, like you do not want to check only at the center, or you do not want to check at only the center and the ends, but you want to check at some 1/3 location or 1/4 location. So using the checkpoints command, you can specify the locations for the checking. So if this is a beam, then you can take a look over here. So you can specify how many number of times you want to divide it, and then you can get the results at those locations. Alright, so that's about the different options available for the steel design. Now let's go ahead and define a design case. Again, just like analysis, we can have a number of design cases to perform the design. So we can assign a different design case for different analysis that we have performed, and again we can choose which members we want to design the structure for. So I'll click on OK and run the design. Alright, so design is performed. Now let's take a look at the design results. Firstly, let's see the status of our structure. So whichever are red in color, they are not good. That means they are failing, completely failing, going beyond 1 ratio. And again, we can see most of the structures are under the need check, which is green in color. Need check meaning it is below the target ratio. Then there is OK, which is lying between the target ratio, which was 0.6 to 0.9. Then there is critical. Critical, there you can see the orange color 2 are there. They're critical, that means they are from 0.9 to 1. They are passing, but still they are in a critical state. Then there is NG, which I just explained. There is failure. None of the members are failure, but however, failure means that you need to actually do change the section property. And then there are members which are not checked if you have not utilized it for performing the design. Now that's one thing. Now further we can generate design reports of our members. You can click over here on design reports and you can have a detailed design report generated for any of the members selected. So that's a column that I'm selecting, a beam and a brace, and then simply click on OK. MIDAS actually generates a very sophisticated Microsoft Word document that has got the information for the parameters that we have inputted, the section property, and you can see all the formulae that have been utilized for performing the design. There's the command ratio and there's a check of deflection, so it's okay. Similarly for another section, which is column member, and further we have got the brace. So for the brace, this is the design calculation that has been provided by the program. So the design reports can be generated for a single member as well, and you can get the design report or the design result in the form of contour. You can get the result in the form of tables as well. Right now over here you can see the design results separately for axial loading. This is the ratio for the bending, buckling, bending in the Y direction. You can for the torsion, see for the torsion and for the deflection and for the fatigue as well. So these are the different ways in which you can check out the results and the table format. So let me just quickly go through the table format. There is steel result table, steel design result. So here we have got the options to check by member. So you can take a look at the result for this column, and here we go, the ratio is there. Alright, so it's a need check type of a member. You can take the results further to the design report generation. Alright, so you can also take a look at all the design results, and then if you hover over, then you can see which of the element you are actually looking at. Okay, so this is about the design results or analysis and design of steel structures in MIDAS nGen. We are going to be looking at the reports and drawings in the next session as well. So we'll go ahead now back to our presentation. Alright, let me tell you something about this MIDAS support service that we have for our users. So as you see, we are providing the training sessions online through mass webinars. Similarly, we do have technical materials available in the form of videos, so that can help you with a step-by-step tutorial. Alright, so let's go to the conclusion of our today's session. So basically, we have seen how the shape model and the analysis model can be combined together, and further we can perform the analysis and design. Then there are so many automated features available in MIDAS nGen, that is auto-generate of load combinations, auto-generate of stories, and there is auto-generate of offsets, many automations that are available in MIDAS nGen. Then further optimization can also be performed for steel as well as for RC. We'll see more that in detail in further sessions. And there are high quality reports and drawings generated by the program. So in the high quality reports, we saw how the design reports are generated in today's session. The drawings will be shown in tomorrow's session as well as it will be shown in tomorrow's session. All right, so that's about it. So we have got a benefit of getting a fast design for bidding and pre-bid information, then we can have a good quality design result for practical design, and we can further get the construction done on time because of the preliminary procedures done on time. So that's about it. Now here we have a special launch offer for our attendees right over here. We are basically having MIDAS nGen subscription for 1 year. The original price of it is $2,400 US. However, the launch price that you're getting is $1,200 US. It's absolutely 50% off. You can take the most advantage of the software solution because there's so much more that you can do. So here's the offer, which is available till 31st March 2019. Trainings and technical support will be provided free of cost. And it's not like there will be mass webinars again and again, like you can have your own customized support session as well. Alright, I'd like to end this session now. Thank you very much for attending our webinar.